If you are watching this video, you are ready to learn how to solve problems involving limiting reactants or limiting reagents. Means the same thing. Just quick review, limiting reagent or limiting reactant is the reactant that limits the amount of product that you can make. It's the reactant that runs out first. Excess reactant is the reactant that is left over during a chemical reaction. So let's see how this works in terms of the creation of water. I've got an example problem here that says how many moles of water can we make when 2 moles of hydrogen gas mix with 2 moles of oxygen gas? So I've got a balanced chemical equation, and of course we always need to write a balanced chemical equation first. So 2H2 plus O2 yields 2 H2Os. Double check to make sure things are balanced. 4 hydrogens, 2 oxygens, 2 oxygens. We're good. So now I know I have 2 moles of hydrogen gas and I've got 2 moles of oxygen gas. Now, unlike the problems that we've done before with mass-mass problems, we now have 2 givens instead of 1. In this case, we've got 2 moles of hydrogen, 2 moles of oxygen, and we need to figure out which one is going to run out first. So, same process here. I put this over a 1 to remind myself that I'm multiplying by conversion factors. This one, I'm already in moles, so I want to go from moles of hydrogen to moles of water in both cases. Because whichever one makes the least number of moles of water is going to be my limiting reactant. And then I want to get rid, in the first case, of hydrogen, so I put moles of H2 on the bottom, moles of O2 on the bottom here. And I look at my balanced chemical equation and see that for 2 moles of water, I need 2 moles of hydrogen. And in my oxygen equation, for every 1 mole, or excuse me, 2 moles of water, I have 1 mole of oxygen. Those values are my molar ratios that just come directly from my balanced chemical equation. So now, I cancel my moles of H2 out from the top, moles of O2 out from the bottom, and I find out here that I can make 4 moles of H2O, a given amount of hydrogen, and I can make big error. Rewind this and pretend I never did this. I can make 2 moles of H2O with 2 moles of hydrogen, and I can make 4 moles of H2O with 2 moles of oxygen. Well, which one's going to run out first? The one that's going to run out first is going to be the hydrogen. So the hydrogen is my limiting reactant. So now I can say I will only make 2 moles of water because my hydrogen ran out first. You can ask yourself the question as well, how much oxygen will I have left over? Well, if I know here that I can make 4 moles of water with oxygen, and I already used up 2, I will have 2 moles of oxygen left over. And that's going to be my excess reagent. So the amount of product I can make is going to be the 2 moles of water. The amount of oxygen left over is 2 moles of oxygen. So, fairly straightforward when I'm dealing with moles, but how about when I'm dealing with grams? So this time I'm going to say how many grams of water can I make if I've got 5.65 grams of hydrogen gas mixed with 2.56 grams of oxygen gas. So always start with my balanced chemical equation. This time my 2 givens are in grams. and 2.56 grams of O2. Put these over 1 to remind myself I'm multiplying by conversion factors. And I also say to myself, I've got to convert from grams of each gas to moles of each gas first. So I put 1 mole on the top. And hydrogen gas, looking at my periodic table, hydrogen, there's 2 of them at 1 gram apiece. So that's 2 grams. 2 grams of hydrogen per mole. And oxygen, I've got 2 of them at 16. That's 32 grams. So 32 grams in 1 mole. So there's my first step. I'm going grams of each reactant to moles of each reactant. Now, I throw in my molar ratio conversion. So I'm going to go from 2 moles of water, because that's what I want to find, from 2 moles of hydrogen gas. And down below here, I want to find how many moles of water I can create from how many moles of oxygen gas I start with, and my ratio of water to oxygen is 2 to 1. So then, grams of hydrogen cancels out, moles of hydrogen cancels out, and I'll be left with moles of water. And I'm going to stop here with moles because I'm going to compare which one makes the least. So I have 5.65 times 2, and I can actually just cancel that out because that's really a 1. And then I divide by 2 here. So 5.65 grams divided by 2 is going to give me 2.825 moles of water. And on this side, I've got 2.56 times 2 divided by 32. All these things cancels out, and I can make 0.16 moles of water. So who's going to be my limiting reactant? My limiting reactant is going to be the oxygen. So oxygen is going to limit the amount of water I can make. So now I've got one last step. I know how many moles of water I made. Now I want to figure out how many grams of water I can make. So I'm going to do just one last conversion. I'm going to go grams of water from moles of water. And in 1 mole of water, look at my periodic table. I got 2 hydrogens at 1, 1 oxygen at 16, so I have 18 grams per mole. So my final answer is going to be 2.88 grams of water. And that's how much water I can make when the oxygen gas runs out first. There's one last piece to this, and let's remember here that I can make 0.16 moles of water. I'm going to use that fact to figure out how much hydrogen gas I have left over. So, how much of the excess reagent will I have? Here's how I figure that out. I take how many moles of product I can make. And remember back on the previous screen, I can make 0.16 moles of water. Put that over 1. And I'm going to convert that back to my reactant where I've got 2 H2 moles to every 2 moles of water. And so I will have used 0.16 moles of hydrogen gas. Well, I know that I started with technical difficulty. Now we're back. I know I used up 0.16 moles of H2. I'm going to convert convert that back to grams of H2, and I know there's 2 grams in 1 mole. So I used up 0.32 grams of H2. Well, since I know I started with 5.65 grams of H2 started, minus the 0.32 grams used, I have 5.33 grams of H2 left. And you can think about reasons why we want to know what we're left over with, because if we have too much hydrogen gas left over, we could have a big explosion, and that's not a good thing. So it's as important to calculate how much we have left as how much product we're going to make. So this is in substitution of me doing this for you as a group in class, because I'm not going to be here on Friday. Hopefully this makes sense to you. Please attempt the limiting reactant problems that are on the worksheet, and good luck. And remember to turn in your labs today as well. That destruction of iron lab is due today at 11:59.